In Unit 13A, Part 2, we are going to use trigonometry to find some side lengths and to find angles in right triangles. A trigonometric ratio, or a trig ratio, is a ratio of the lengths of two sides in our right triangle, which, remember, ratio is just comparing two numbers together, and we can write it as a ratio, or we can write it as a fraction. And we have three of them that we are going to look at. One is the tangent ratio, sine ratio, and cosine ratio. And you want to make sure you do not forget this. It's your opposite leg over the adjacent leg of a certain angle. So looking at our picture over here, it's all based off of angle A. So based off of angle A, the side opposite is our side BC, and the side adjacent to it, so adjacent means it connects it to the right angle, and the adjacent side for angle A is side CA, or AC. So we write it as BC over AC, and we would fill in whatever measurements are of that side. Same thing is going to work for sine, except we're going to use the side opposite of angle A, so that'd be right here in green, over our hypotenuse. Remember, the hypotenuse is always across from the right angle. Cosine, so we abbreviate it as COS, is the adjacent over the hypotenuse, so that would be my blue piece right here over the hypotenuse. Now remember, it's all in relation to a certain angle, so this is the angle part that we would put right there. We're going to do number one together, and then number two you're going to do by yourself. So on the first one, we are just going to label the sides as either adjacent, opposite, or hypotenuse in relation to the angle that's mentioned. On number one, it's based off of angle A, so my opposite would be side BC, and I'm just going to label it as OPP, so that would be my opposite side. Hypotenuse then would be always across from the right angle, so that would be my side AB, and I'm going to label it as my H. Adjacent then will always connect it to the right angle, and that's going to be my A. So sometimes we're going to use H, O, and A to abbreviate the opposite, hypotenuse, and our adjacent. I want you now to go through and do the exact same thing. For number two is I want you to label the sides in relation to angle B. Now that you've done that, your opposite should be over here as AC. Your adjacent should be your BC, and hypotenuse would be your AB. What we are going to do next is we need to set up the fractions now with actual numbers in there. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And it's all in relation to a certain angle. So for this first one, we're going to label it based on angle J. So my 24 would be my opposite, 32 would be my adjacent, and 40 would be my hypotenuse. For sine, I need to do opposite over hypotenuse, so that would be my 24 over 40. The reason I'm writing it right here is because we do need to reduce it. And when we reduce it, we would get a 3 out of 5. So my answer would be 3/5. So the sine of J is 3 over 5. Cosine of J, now I want you to try this one yourself. It's adjacent over hypotenuse. Adjacent, you should have put a 32. Hypotenuse is our 40 again. When you reduce it, always make sure you reduce this fraction. You get 4 over 5. So 4 over 5 is what you should have chosen for your answer. Tangent is your opposite over adjacent. So 24 over 32. When we reduce it, that gives us 3 over 4. So 3/4 is our tangent of J. So it always makes a difference of what the angle is as well. For down here, we're going to do the same thing, same triangle, but now it's based off of angle K. So the sides we label will be different based on the angle that we are using. The hypotenuse is still the 40, but adjacent and hypotenuse are switched. For the sine, I want you to set up sine now and make sure you reduce your fraction. The sine of K should be your opposite, so 32 over your hypotenuse, 40. When you reduce this, you would get 4 out of 5. Cosine then, remember, is adjacent over hypotenuse, so adjacent is our 24, hypotenuse is the 40. When we reduce it, we would get a 3 out of 5. I want you to try the tangent one now, so you get one of each of them. And now go ahead and set up your fraction for tangent and reduce your answer. Tangent would be opposite, so my 32 over adjacent, 24. When we reduce it, we get 4 over 3. On number 4, one thing that I want you to do first is you need to use Pythagorean theorem to find the missing side, which is right here. So go ahead and do that to find what our missing side is going to be in the right triangle. This is the equation you should have set up. When we simplify, we get 64 plus x squared equals 289. When you subtract your 64, you get 225. And then we got to undo the squared, so we take the square root, and we get 15 for that missing side. So that's for both of our triangles down here. On the first one, we are basing it off of angle J. Second one, we are basing it off of angle K for our labels. So I want you to go ahead and start labeling your 3 sides in this first triangle. The 8 should be the opposite. 17 would be hypotenuse, and your 15 would be adjacent. So next, I want you to fill out all 3 of these and make sure you reduce your answer. Your final answer should be 8 over 17 for opposite over hypotenuse. Next would be adjacent over hypotenuse, so 15 over 17. Tangent is your opposite over adjacent, so 8 over 15. On this very last one, your opposite would be the 15, adjacent would be the 8, and your hypotenuse would be the 17. For the sine, you have your opposite over hypotenuse, so that would be 15 over 17. Your cosine is your adjacent over hypotenuse, so it would be 8 over 17. And tangent is opposite over adjacent, which would be our 8. And now none of these reduce, so that would be your final answer.